Sound speeds. And let me start out by saying that I am so happy to finally have this video done. I have been testing the Theos system for months. It's taken forever for me to finish all the different testing. And every time I think that I have done all the testing, there's more things that I think of and end up testing. But guess what? I have to draw the line someplace. And this video is already going to be released far later than most other videos out there, but it's also going to be a much deeper dive than most other videos out there. And for that reason, I'm not going to cover the same stuff that everyone else has. As a matter of fact, when I first saw the Theos system, I was with Curtis Judd at his studio, and he and I both did deep dives in on the Theos system, and many of our findings made it into his video, but not all of them. And then from there, I took some of the things that he didn't put in his video and some of the things that I later found out on my own and have put them into this video. So let's get this thing going. But before we get going, full disclosure, Deity did send me the entire Theos system that you're going to see in this video in exchange for a fair and honest review. I do get to keep it following this review, but I'm not going to allow that to affect my opinion, so you expect this to be a fair and honest review. Straight out of the gate, I am really happy with two big thumbs up that Deity included two W-lobs in the Theos system. I was hoping years ago that they were going to include the W-lobs in the DBTX system, but they didn't, despite my recommendations. But guess what? They did on the Theos system, so all is forgotten. Now that we're barely getting started, I'm going to say pause right here and go away. Go away and watch Curtis Judd's review of the Theos system if you have not already. Why? Because he does a great job of covering the Theos and what it does, how it looks, and all the stuff that I don't want to waste my time going back over since he and everybody else has done it. But Curtis, by all means, has done a fantastic job of covering everything that most people would want to know. But if you're looking for a deeper dive than anyone else is crazy enough to do on YouTube, that's why you're here and going to continue on from there on. But hey, if you watch it from here on out, I will have expected you to have the prerequisite of watching Curtis Judd's review of the Theos already in the bag. So there you go. Just as we saw with the Deity Connect system, the D2RX dual channel receiver that comes with the Theos system has the ability to go out via a USB-C digitally into your computer. The first thing we're going to test is Deity's claim that the Theos records with an EIN of negative 130 dBUA weighted, which is exactly in line with products like the Sound Devices Mix Pre series. I did two series of EIN testing for this video. The first was with a 2K ohm resistor, which is much higher than standard, but it's what Deity originally told me was what their input spec was rated at, and so I went with that until I later saw the 150 ohm resistor listed on their website and redid all the testing with that one. All the tests that you're looking at were shot using the 2K ohm resistor, but it took such a long time for me to prep the footage for this video that we're going to use that footage and you're going to like it. You'll note that these EINs are quite a bit higher than most recorders on the market and that the noise floor is lower when you record in 24-bit as opposed to 32-bit floating point with a gain setting of anything other than plus 27 or 30 dB, which is where the 32-bit floating point recording would win. But yes, I did redo this testing and with a proper 150 ohm dummy, and since EIN is measured at maximum gain, this is the only result that we really care about. The number you see is with all the calculation adjustments, and you'll notice that it's exactly in line with Deity's claims. As long as you gain stage correctly, you won't notice a difference in the recorded noise between 24 and 32-bit recordings on the Theos. This is why it's so important for you to use the proper gear when you do testing. With the 2K ohm resistor, the results were skewed as much as 12.5 dB higher in noise floor than it was when I used the proper 150 ohm resistor. And believe me, I was so happy when I got the results that I did, and that just shows how much a resistor can matter. But that's just testing the EIN of the recorder on the DBTX, which is Digital Body Pack Transmitter in case you're curious. It's not testing the EIN of the throughput through the entire system. Since most people are going to be using the analog out of the Theos, I connected up the included cable to the D2RX, that's Digital Dual Channel Receiver. And then from there, I connected this up to my Sound Devices Mix Pre 6, set an output level of 0 dB line level, and on the Mix Pre 6, I set an input line level of 0 dB, and then from there, started my testing. I ran a negative 50 dB test signal into the DBTX at the maximum gain setting of plus 30 decibels. And from there, I added on the 150 ohm dummy resistor, and then I performed a bunch of calculations and adjustments in post and came up with the overall level of negative 100 dB. And by the time you subtract the 30 decibels of gain, it's right at negative 130 decibels. But I want to point out something. Here's the chart with my measurement data from the 2K ohm resistor test. Notice that although the input gain goes up in 3 decibel increments on the DBTX, the actual amount of gain increased isn't linear. The actual difference in gain between plus 15 and plus 30 decibels, for example, is only 12.16 decibels. In short, at maximum gain, the EIN holds true at Deity's claim of negative 130 dBu, but the gain may be up to 3 decibels off depending on the gain level that you set it at. Use these numbers as a reference and use your ears to actually set the level, though, and you'll be fine. Everybody on YouTube does wireless distance tests with a clear line of sight. So I'm not going to. No, instead what I'm going to do is see how well it punches through walls. The previous Deity Wireless System was based on the consumer 2.4 GHz frequency range, which sometimes has issues punching through even the thinnest of walls. The DBTX is paired with the dual RX on this side, and as for the DBTRX there, it's paired to the DBTRX here. Now what I'm going to do is take... Looking back, we can kind of laugh at how terrible that result was, but geez, that was bad. But the Theos system is based on a UHF frequency range, which is almost a fifth of what the 2.4 GHz spectrum is. And that lower frequency means that it's going to be better at punching through walls. Why? Well, think of a nightclub. The lower frequencies like bass go through the walls very easy, but the higher pitch sounds like the mid-range and treble, those don't go through the walls nearly as much. Proof of the pudding? When you walk up to a nightclub, you hear doo, 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 as opposed to the very, very high-pitched sounds. That said, I'm going to be using the lowest possible frequencies on the tests going forward. And on that note, what you're going to be hearing is going to be the Theos, but if it cuts out, it's going to drop in level because you're going to be hearing the camera mic instead. That way, in case you're curious as to what I'm saying, you're still going to be able to hear it. It'll be very obvious as to what you're hearing if the audio pops in and out, but will there be any static? No, because the Theos is a digital system. In the analog transmission world, if you have 5 bars and you suddenly drop to 1, it turns into a staticky mess. And it's all static when you drop down to absolutely no bars and there's no signal at all. But the Theos is a digital system, and in digital modulation, the difference in sound quality between 5 bars and 1 bar is 0. If you get it, you get it. If you don't, you don't. If you drop down to 0 bars, it pops out. If it comes back on with even 1 bar, it's going to be the same quality as is with 5 bars. That's just the nature of digital. Now, on that note, let's do some testing. I just smart tuned, and the frequency it dialed in on is 550 megahertz, and I'm not going to use the duplex gap or any of the alternate frequencies that are reserved for Part 74 FCC members, because not everyone has a license like that. And if you don't, then you should check out this video right there, and it will explain to you why you need to get one. But for most people out there, you can use non-FCC licensed frequencies. Now, I'm going to hope that this lav stays on there, and I'm going to explain to you what I'm doing here. I have the DBTX recording the signal from the receiver over there. Now, I'm going to take a short walk here, and what we're going to be testing here is going to be to see if we are, I'm sorry, it's going to be noisy here, but we're going to see if we can transmit through a lot of different things. Okay, right now I am getting out of a truck and we're directly line of sight to the receiver. So the transmitter's in my pocket here, and what we're going to do is take a little walk here. Keep in mind that RF hates metal. So as we start transmitting, hopefully through things like this metal truck, then you're going to hopefully hear everything. But if not, we're going to resort to the mic that's on this camera. Now, these containers that I'm walking through have metal on it. Okay, this is metal, and there's 2 sides to every container. So as I start to walk past them, it's going to be transmitting through multiple containers. Right now, it's going to be going through at least 2 walls, this wall and the inner wall, plus the truck itself. And as I start to walk back, you're going to start to see more and more of these containers entering the frame. And every one of these containers here has 2 walls to it. So we're going to see if I can walk all the way around this truck, which is going to be a lot because it's also transmitting through my body. And if we can get all the way through this, you're going to know that it can transmit through multiple layers, probably 5, 6, probably up to 9 layers of things as of right now, because it's transmitting through every one of these containers plus whatever's on the inside, and they do have things on the inside. So we're going to continue to walk on back around this side of the truck, and it's transmitting through 9 layers again, probably around 7 now. As I get on closer here, we're going to transmit through probably 5 at this point, and we're approaching 3, coming up on the back of the truck, which is going to be 1 layer of the metal right there. And now we're walking around to the front of the truck, so we're going to see if the transmitter is picking up everything right now. Hopefully it is. It's basically going to be the very best possible scenario, being a low frequency like this. If it was a higher frequency, it's not going to be able to punch through nearly as many walls. And if you lost me at any point, you'll know that that's about how many layers you can go. The Theos did surprisingly well in that test, and metal's not easy to transmit through, much less multiple layers of it. So why don't we do another test, and this time add more distance and even more obstacles and see how well the Theos does. So for this test, we're going to be wrangling in Sean Milo. He's going to be helping me with this test here by guarding the gear. And I'm going to take a walk here, and we're going to see exactly how far the wireless range is going to be. Now, to give you an idea, I did scan on the Theos the air. I put it on the lowest frequency range because we're going to be punching through a lot of metal in this video, in this test rather. So as I am walking right here, it's still line of sight. Well, with exception of the back of the bench that he's sitting at. But as I start to walk around here, it's going to start to get a lot of metal interference. We're going to start to hear a lot of that. And I am going to predict that by the time I get to the stairwell over here, it's going to be long since cut out, if it's not even cut out now. Now, what we're doing is I have the wireless microphone up inside my hat here. So if you're catching wind and stuff like that, that's why. I'm sorry about that. It's one of those things where when I got out of town, I realized that I forgot the heavy duty wind protection, and the Theos doesn't come with any. All right, so I'm approaching the stairs and we're gonna see if it's gonna cut out here. So here we go, starting to walk down now. Normally I would put the transmitter on an ankle, and by now it'd be buried, you know, way down. But this is kind of like the same thing. It's going to be low, and, you know, hey, what am I going to say? Except we are at a lower level now than an ankle would be because we're on a whole different floor. Going in through here, and at some point, we're going to hear it again coming through the wireless, and we're going to find out exactly what point that is. So there's a theater directly here to my left. They're not currently transmitting anything, so we don't need to worry about interference or anything like that. Plus, being completely honest, we're in another country. So I intentionally did not connect up the Theos to my phone because I didn't want it dialing in on the power and the frequency ranges that are legal in this country. I mean, I'm not gonna say what country it is, even though the more astute people would probably say, I know that country. Anyway, there is our wireless test. We're now line of sight back to the Theos receivers. And we're almost back to Sean. I tell you, whenever you go out of town on something like this, like where I am right now, it's like you're trying to put on weight. And I don't like it. It's making it hard to walk. At what point did I cut out?
Right after you said you'd normally wear it on your ankle on the way down, about less than 30 seconds after that. It cut out, glitched, and then stopped.
So that's about the time I walked down the stairs, right about the time I predicted.
And then I heard you saying, you're gonna hear it again. There's a theater right here to my left. That's when you came back in, and then I had you all the way until you were line of sight.
So it's pretty much right as that whole area. So it's good that I didn't walk all the way down there because it would have cut out a long time ago. Okay, well, good. Test number 1 complete. Considering the distance and obstacles ranging from thick iron walls to whatever was behind them, the Theos did really well again. So why don't we this time do a long range test, but add in a few layers of badness. We just did a line of sight test down here, and unfortunately, despite being line of sight, it failed miserably. Tell us why.
If you can see those 2 metal tanks distance back there, as soon as he was around those, it was dead.
So basically, we didn't even have much of a test. I'll show you what we recorded. What I'm going to do is, this is technically a line of sight test, but we don't really have a full line of sight. I'm hoping that the windows directly to my left are not in some way pressurized. They look like they're single pane. Maybe they're double pane. I don't think they're going to have any kind of a gas in there that's going to hinder our ability to really pick up sound through them. So that's what we recorded, and it's not much of a test if before it even starts, it's dead. Seriously though, any sound mixer that allows talent to get a few hundred feet away from them on a cruise liner through all those obstacles deserves to have audio dropouts. This is kind of fun. Now let's do one final range and obstacle test, but this time in a different area of the ship, and we're going to see how well the Theos performs there. Way behind me back there, Sean is sitting there with the receiver. And I'm going to take a little bit of a walk this way, and we're going to see if, knowing that we're starting line of sight right now and there's no metal that gets in the way, if we're going to be able to get any kind of a better range, more or less line of sight. And so I'm going to walk a little bit back here, and we're going to see if this more or less is line of sight. So we're going to see if it is picked up. Now, I'm recording on the DBTX way over there at the receiver. So this isn't recording. Nothing on me is recording, but if you happen to hear it flip to me, then, as you've seen in previous videos, it's because I turn on the camera mic right there. And so there might be a lot of wind or something. I'm going to suddenly sound like garbage, but hey, that's the nature of our wireless. You might say, what is he saying? I want to hear what he has to say. All right, I'm going to walk on up here, and just in case it works this far, which, to be completely honest, I'm not 100% optimistic about, I'm going to go past this metal, and then I'm going to walk up the stairs. And we're going to see if he's able to get me line of sight all the way through here. And if so, it's going to be awesome. But like I said before, I'm not holding my breath. I don't think there's like no point of optimism here. But who knows? Weird things have happened, and under no circumstances are you allowed to play music, because I cannot have this video copyrighted. So I don't care if there's a few thousand people here. Their happiness is not going to change at all just because they kill the music here for a second. I can't go outside there. Actually, you know what? He may be able to catch me here because I'm line of sight. We'll see. Hold on a second. There he is. Raise your hand if I'm line of sight and you hear me. So he can hear me way over there when I'm on this level. So I don't know what point I cut in, but you'll already know because you're watching this video.
Needless to say, I am very impressed with the results of this test. Now, keep in mind, this was at a transmit power of 100 milliwatts and at the lowest possible frequency that the Theos can transmit at, which is 550 megahertz, which just so happens to coincide with the exact frequency that the scan picked for me in both the cold and warm weather. Before we move on, I'd like to mention something. The Theos allows the user to select from multiple frequency ranges, and some of those require a Part 74 FCC license to operate them legally in the United States. Now, what I would like to see is a little Part 74 to show up next to the frequency range selection. That way, the lesser informed people will know. Maybe if you select a frequency range that requires an FCC license, a little screen could pop up informing the user that it requires a license to operate in that frequency range. Okay to accept? When you run a scan, not only will the Theos give you the option to pair up to 2 DBTX to the D2RX, but it also will give you a list of spare frequencies in case you have additional wireless units and you'd like them to cooperate. You can also go old school and run a scan on the other systems once you frequency coordinated the Theos system. But keep in mind that you're going to want to keep on any transmitters that you've already frequency coordinated. That way the other systems can see what they're dealing with. On that note, let's talk modulation. I wanted to see the Theos transmission, and it looks quite healthy, fitting within the advertised 100 kilohertz frequency steps. Sometimes transmitters have issues with RF spray, which is undesired and unexpected transmission and emissions that can happen from wireless devices affecting nearby electronics. So let's test this and see if it does any of that. Where in the world are we, Curtis?
You wanted someplace without radio frequency interference.
Yeah, normally I walk into my living room, but it's okay out here in the tundra. So what we're doing out here is, again, no RFI and EMI interference. And because we have a big brain here, I'm going to ask a couple of questions, and hopefully he can steer us the right way on this. What is EMI and RFI?
EMI is electromagnetic interference, and RFI is radio frequency interference. And radio frequency is something that's transmitted usually through the air. Electromagnetic is usually tied with something where current is flowing through something, and it creates a magnetic field around that. So
this would be what?
This would probably be, this would be radio frequency,
definitely,
obviously from the transmitter pack. But there's some power here. Probably not going to see significant EMI, to be honest. Just not a lot of current.
There is a potential for anything electronic to have some sort of EMI. So what we're going to do is use an EMI and RFI meter. Now, what this is able to do is it scans anything in front of it to see if there's a level of EMI or RFI. And if there's a dangerous level, it will go red on the front and you'll hear a beeping.
If it's really dangerous, then it will go flashing red and it'll beep extremely loud. So what we're going to do is scan the Deity Theos system out here in the middle of nowhere. I don't have a cell phone on. He doesn't have his cell phone on. There is no interference anywhere near us. So if you would be so kind as to turn that on, of course I ask you that when you're wearing gloves. And so we'll see if when it's transmitting, if it's going to have any kind of a problem with EMI or RFI.
Okay, we're up.
Okay, would you hold that up, please, just like it's on the side of a body here. Let's do this.
This way.
Because this is the way that it would go onto the body on one side. And I'm seeing a 0 on everything. This thing, it is transmitting, right? It is on?
Yeah. Let's double check the...
You seeing the meters moving?
Checky, check. 1, 2, 3. I'm actually not seeing them. Oh, there it is. Yep.
Yeah, I saw like it went up to 1.
Yeah.
Let's try turning it around the other way and see if it's any different there. Now, why are we using the lavalier on the transmitter when we do this test?
Well, not so much in the kind of the more modern systems, but I think in some of the older systems there were cases where they used the wire for the microphone to help with reception.
Yeah, that's right. And it's not necessarily something that's used in the modern era, but we'll see if Deity is going retro. Yeah. I saw it jump up to 1 and that's like the tiniest little bit. That's 1,000th or even a 1,000,000th. So now that we have an airplane.
You want to try something else here? We're at 50 milliwatts on the output right now. Do you want to go to 100?
Yeah, let's go to 100. Let's see if that makes any difference.
Let's pop it up there.
And actually, I'm going to turn this thing into hold any kind of a peak level just to see if it gets anything. Okay. It will hold it.
We are now at 100.
Okay, so this would be if it's on a person. And I'm still getting a 0. How about in the back, the other side of it, the front? So if you turn it, you put the clip on someone's belt, and then it's facing inwards toward them. I'm getting like no emissions at all. So this thing is extremely safe to put on talent, even if you don't like them. Another solid test result for the Theos. But for this next test, I'm not so sure. Let's listen. The Theos transmitter is set to 30 decibels a gain, which is maxed out, and there is no digital or analog limiter on the Theos transmitter. Going out of the receiver, it's going digitally directly into my computer where I'm recording it, and I'm bringing the microphone closer and closer to my mouth so that way we can see if it is going to distort, because you cannot transmit 32-bit floating point audio. You can only transmit up to 24 bits. So if this is distorting, that means that the Theos does not have an analog limiter, which is a big design flaw in my opinion. As expected, the DBTX clips like crazy if you don't set your gain properly, and I'm not happy at all that Deity chose not to include any kind of a limiter inside the DBTX. However, silver lining, if you're in a country other than the United States, you do have the option of transmitting and recording, even in 32-bit floating point. If your audio clips, you can recover it. Oh joy to not be in the United States. But there's hope on the horizon with the DLTX. Not only does it feature 48 volts fan to power for condenser microphones, but it also includes an analog limiter and encryption. But that's not on the DBTX. So here's what I'll say. No analog limiter equals fail. Since we mentioned recording, I want to point out something. If you turn on always in the record menu, the DBTX will begin recording as soon as you turn it on. You won't receive a warning, nor will it transmit in the United States due to Zaxcom's patent on transmitting and recording at the same time. I recommend leaving it on manual. That way you don't wonder why your transmitter isn't transmitting. With the Deity Connect's BPTRX unit, I measured the input and output levels and found that on any output level other than 0 dB, you had to choose between an elevated noise floor and a non-flat frequency response. Now, this has been improved quite a bit on the Theos system, even though it's not quite perfect just yet. Now, I'm about to start throwing a lot of test result data at you, so you might want to be prepared to hit spacebar, which is pause, or slow down the video if you're curious to see the data. The frequency response is more or less consistent regardless of your output level, so you could choose anything between -20 and +10 dB with confidence. It's nearly flat between 100 and 10,000 Hz, but below 100 Hz and you lose about 2 decibels by 40 Hz and another 4 decibels by the time you get to 20 Hz. Between 10K and 20K though, you'll lose only about 2 decibels. Perfectly acceptable for dialogue. The Theos isn't a noisy system like the Connect was, nor do you gain or lose certain frequencies based on your output level. So feel free to set whatever output level you would like without worrying about noise or wonky sounding audio. As for the inputs, well, we talked about the noise floor already, but what about the frequency response? I wanted to isolate each gain stage on the Theos, the input and preamp quality recording directly on the Theos transmitter, the same exact thing but transmitted to the receiver and going digital out to record digitally on my computer, which should be the exact same quality in a perfect world, and the exact same thing but instead of recording digitally, record analog out instead. So first, let's look at the analog input preamp quality and the analog digital converter. Once an analog audio signal enters the DBTX, it is converted into a digital file which can be measured under certain conditions. I prepared an audio file and then played it into the DBTX twice. The first time I recorded it directly on the Theos transmitter, and the second time I transmitted it over to the receiver and then recorded it digitally out into my computer. This is going to allow me quite a bit of flexibility. I have already prepared a digital audio file, and that is going to be recorded on the Theos DBTX. Now, the difference between those two files is going to be what is done on the input of the Theos, the preamp, and the analog digital converter. Any differences between the two of them are straight up related to the input and conversion to a digital file. Now, once it's digital, it's zeros and ones. That file should be the same as anything down the line that's recorded digitally. The difference would be the transmission quality. So if in a perfect world, I am transmitting, there should be absolutely zero difference between the transmitted audio and an audio file that's recorded on the Theos. Any difference would be the quality of the transmission. My friend Nick Ramsberg ran a few file comparisons for us through Delta Audio Null Comparator and helped analyze the results. This software is very powerful and is designed to align and compare two audio files, present a detailed report, and even output the difference between the two files using its own version of the subtraction test. As we listen to the difference between my original audio file and the one recorded on the DBTX, keep in mind that the sound you hear is only the difference in the audio between the two files. The more you hear, the more the audio has changed from the original file to when it was recorded on the Theos. This audio file is going to be normalized to 0 dB and then leveled also to 0 dB, so that way we could try to see if our audio level is peaking at just below 0 dB, what exactly it's going to sound like when played back over the Theos. If the Theos has a digital limiter or an analog limiter, then it should peak differently than it would be if it does not have any limiter at all. One thing we noticed was the slightly diminished dynamics and less than full amplitude compared to the original audio file, especially in frequencies below 1000 Hz. The audio file I played was normalized to peak at 0 dB and was leveled to -16 LUFS, so the tonal shift may be related to the preamp being overloaded, but the file didn't clip, so I suspect the ADC quality over dynamics would be the reason. You may think that there's a lot of data missing, and to a computer there may be, but if I didn't tell you, you probably wouldn't notice anything was missing unless you're recording sounds below 800 Hz where the sound attenuates up to 4 dB, or you're comparing the loudness unit spec. The frequencies recorded are a perfect match in the human hearing frequency range, so now let's compare the audio as it was recorded on the Theos versus the audio after it was transmitted and recorded digitally on my computer. This audio file is going to be normalized to 0 dB and then leveled also to 0 dB, so that way we could try to see if our audio level is peaking at just below 0 dB, what exactly it's going to sound like when played back over the Theos. If the Theos has a digital limiter or an analog limiter, then it should peak differently than it would be if it does not have any limiter at all. The difference between these two files shows the return of the scratchy sound that we heard on the BPTRX system. It's a fuzzy, staticky kind of sound, and one that isn't unique to the Theos system. All the major players in wireless demonstrate these artifacts to a degree in their own ways. The aligned waveforms show slightly more amplitude across the whole spectrum with areas of a perfect matchup, but the most noticeable thing happens above 14.3 K, where the transmitted audio attenuates by up to 25 decibels. That's a lot, but luckily there's not a whole lot of data in dialogue recording that lives up there. To see how much was changed on the transmission alone, we have to compare the Theos recorded file to the file recorded on the computer. This audio file is going to be normalized to 0 dB and then leveled also to 0 dB, so that way we could try to see if our audio level is peaking at just below 0 dB, what exactly it's going to sound like when played back over the Theos. If the Theos has a digital limiter or an analog limiter, then it should peak differently than it would be if it does not have any limiter at all. The two audio files would cancel out, leaving a completely muted file if the transmission were perfect, so the difference between the two files shows us how much the data has changed through the transmission. The loudness is a perfect match, backing up our earlier findings in the analog to digital conversion. The aligned waveforms look the same as they did in the previous test, indicating that the amplitude changes are related to the transmission, but the loudness is a perfect match with zero deviation. The same 14.3 roll-off is present, so we know now that it's entirely related to the transmission of data. Everything else seems to be a perfect match. The difference in what we hear may even be related to jitter. One thing we haven't looked at is the frequency response of the analog input on the Theos. In 24-bit, you'll notice that regardless of the gain setting, the input is flat above 60 Hz. Below 60 Hz, there's a slight roll-off by up to 4 dB, and at some gain settings, this roll-off doesn't start until closer to 50 Hz. The quality of the input isn't related in any way to the recording bitrate of the DBTX, and this can be observed when you look at the exact same thing, but in 32-bit mode. Yay for pointless tests! With that, my testing is complete, but now a few additional things. Now, some of these things I discovered when I was with Curtis at his studio, but they didn't make it into his review. And some of these things I discovered on my own. Yes, it is possible to use the Theos without it connected up to the Sidas audio app at the same time. I did this in another country using the same transmit power and frequency ranges that are legal in the United States, whether I should have or not. If you purchase the US version of the Theos, it's not going to gain the ability to transmit and record at the same time, even if you connect it up to the Sidas audio app in another country. It's only going to change the transmit power and the frequency ranges legal in that country. It would be nice if there was that little ribbon down here that you use to shoot the batteries across the room. I mean, it's not like it's very difficult to remove the batteries anyway, but the ribbon is nice and it might save you 1 second. Also, since we're looking at it, this battery door, if I were to name one point of failure on this entire system, I would predict that it's going to be this battery door. It's not exactly the most stable thing. It makes a little wobbly type sound and feels a little wobbly. It's not necessarily that it's going to break, and I have extensively tested this Theos system quite a bit. It's never broken or even indicated to me that it was going to. If I were to guess, though, I would say that is probably the first thing that would break on most systems, though. Just a hunch. I've had excellent performance out of the Deity branded lithium batteries included with the Theos system, but I do have an issue with them. Disposable batteries like these Deity branded lithiums don't print the milliamp hours they are rated for on the battery. No brand does except Deity, to my experience. That's something normally reserved for rechargeables. So if at a glance, if you were to see the milliamp hour rating on the battery and assume that you could charge them, don't. Big time fire hazard. Bad, bad, bad. And I hope Deity removes that rating from their disposable batteries in the future before someone makes a mistake and goes boom. There is a 48 millisecond delay on the transmitter's headphone out, and there's only a very slight delay on the Theos system itself from one side to the other, not anything like the Connect system. But this is inherent and related to the digital analog converter going to the headphone out. Now, here's what I'm going to say. When you plug into it, it's a little disorienting at first, but you get used to it fairly quickly, and it's really not like you plug up to it and listen to it for an extended period of time. Deity advertises the Theos as having Intermod free transmission, and this is true, not just of Deity Digital Wireless, but of all digital wireless. Some things I like to see on the Theos system: if you press the up and down button at the same time, it takes you to the timecode menu. But wait a minute, if you press up and down at the same time again, it takes you to the record menu. So what I would like to see is a shortcut that takes me to the scanning, frequency scanning menu. So maybe if I pressed up in the checkbox at the same time, well, it takes me to record there too. Up and down, record also. How about down and check? It takes me to the time code. I mean, it's kind of weird and inconsistent. I would like to see those three combinations, up and check, or down and check, maybe to take me to different things. The record menu, time code, and frequency scanning. Or maybe in the menu, they can give us the option to set shortcuts to what we want to go to. I would also like to see an option for an audio mute if you were to plug in a lavalier microphone, or maybe keep it muted anytime something's not plugged up to it. Either way. Lastly, inside the Sidas audio app, I'd like to see a confirmation pop up or require a double press with a visual acknowledgement if you mute a channel. I accidentally hit that mute switch all the time, and it drives me crazy because I have to troubleshoot why I'm suddenly not transmitting anymore. I also want to tell you what the Morse code at the bottom of the Theos reads. Safe and sound. How cool is that? So in case you haven't figured it out already, I love the Theos system. It's what I wish the BPTRX system was, and at a price point of less than $1,100 for a dual receiver and 2 transmitters, it's better than the end users deserve, myself included. These are the first products in the Theos line, and I'm going to predict right now that there's going to be a change in the wireless landscape in the future. And if I were a professional wireless manufacturer, I might be more than a little nervous and downright scared of the future, especially when Zaxcom's patents come to an end. Thank you for tuning into this episode of SoundSpeeds. Be sure to tune in the future for more deep dives on products, reviews, and as always, sound advice. Have a question you'd like answered or want to add something? Be sure to write it in the comment section down below. You can also make a suggestion for future topics of discussion. Again, comment section down below, or you can email me at soundspeeds@yahoo.com. Be sure to subscribe and turn on notifications so you won't miss out on future sound advice.